Okay, hello everyone. Just wanna go through the 5C again after you've gone through the previous video. Had some practice. I just want you to listen to my explanation so that you have a much deeper understanding. Okay, the unit circle. The reason it's called a unit circle is because the center is 0 and 0. Okay, and has a radius of 1. So you can see that's 1 and that's 1. Okay, and that is the reason we call this a unit circle. And as you know that the theta, if I want to represent a theta in the unit circle, I could actually either rotate on a anti-clockwise or rotate on a clockwise. If I do rotate on a clockwise, I'll end up with a negative theta. If I do rotate on the anti-clockwise, I'll end up with a positive angle. What does that mean? Is if I have a Cartesian plan and I want to rotate anti-clockwise to here. So I have to rotate 270 degrees. In other words, 3 pi on 2. Okay, this is a positive angle. Or alternatively, I could actually rotate negative 90 degrees. And this negative only means direction, okay? The negative sign only means direction. Okay, negative 90 degrees will be pi on 2. Okay, so basically, if I want to represent an angle, say for example, if I know a position P, I could have infinite possibility of angles. So I could rotate theta and I could rotate again to end up with an even larger angle. I could rotate again. You can see that it could actually do infinite rounds. Okay, and I can also have negative angle and rotate again, getting here. So basically what I mean is I could just do this. Okay, and I could keep doing. Okay, so you have infinite possibility of angles. Okay, so it's like here, if I rotate negative 90 degree and then I rotate out, like I don't use the negative 90 degree, I keep rotating again. So, and again and again. So you end up with infinite angles. So here is a unit circle. It is good to build up a right angle triangle and then do things from the right angle triangle. Oops. Okay. It's good to do things in a right angle triangle. Okay, so I'm just going to highlight the right angle triangle. Okay, it's a right angle triangle. So because the hypotenuse is 1, so from SOHCAHTOA, I know that sine theta is b over 1 is b. Cos theta is a over 1 is a. So instead of using PAB, I could well using cos theta and sine theta because cos theta is a, sine theta is b. Okay, so in the Cartesian plan, a normal Cartesian plan, if you have a point P here, 2, 3. So what does that mean? That's positive 2, positive 3. Okay, and if you have a mirror image of here, P dash, that would be 2, negative 3. Does that make sense? Okay, but what I want to say that is the physical length of here is 3. And the physical length here is 2. And in the P dash, the physical length here is still 3. The physical length here is 2. Okay? Because you just, when you talk about physical length, you actually means the distance. It's a physical thing. Does that make sense? Okay? So if I build up a right angle triangle here, and then I can have that's 3, 2, 3, 2. Okay? But P dash and P have the opposite of y coordinate because they're in a mirror image. So now back into this unit circle graph, you know that B is actually, I can just use sine theta. So basically in the unit circle, because the hypotenuse is 1, the length of these will represent the value of the sine theta, and the length of these will represent the value of cos theta. Okay. So yeah, so as you know, like if you compare that with the 2 and 3, you understand why that it actually represents length. So we can see that cos theta is x coordinate of P, and then sine theta is the y coordinate of P. How do I get these relationship? Okay, from the circle. Okay, we've learned circle before. We have a formula for circle. Still remember that. So our formula for circle, oops. Our formula for circle is x take A plus y take B equals to r to the power of 2. Still remember that. X and y are points on the circle, okay? And A and B are the center of the circle. And r is the radius of the circle. Still remember that. So this relationship actually comes from the circle. So why would I say that? Okay, so P is AB. So I can actually just using PAB to represent. So A would be cos theta. Take away the center of the circle is actually 0, 0. Plus y take sine theta to the power of 2. It's a unit circle, so of course the okay, so it's a unit circle, so the radius is actually 1 to the power of 2, which is 1. Okay, so how about I simplify that? That will be cos theta to the power of 2. Okay, cos theta to the power of 2 plus sorry, this is not y take, sorry, I just realized I made an error. So this is sine theta take 0. Okay, sine theta to the power of 2 equals to 1. Okay, so basically this is the formula of here. This is a very important formula that you're gonna have to remember all the way to your year 12. Okay, so normally in a cos theta to the power of 2, we can write cos to the power of 2 theta. So we could actually write the to the power of 2 here. So, and similar with that one. So it's just a way of writing. So there's nothing really fancy behind it. So you can just write as plus sine theta equals to 1. Okay, so you can actually see that it all comes from the same formula, the circle formula. Okay, another thing I want you to pay attention to is that you can have a look. The hypotenuse is 1. Okay, so in any right angle triangle, so the hypotenuse is always the longest side. So this side and that side, it can't be longer than the hypotenuse. So really, if you think about it, the P is moving, and moving. It could be here. Okay, that P could be here. And there's a right angle triangle here. What is the maximum of this side? That would be when P is to here. Can you imagine that? So if I keep moving P, okay, and then I keep moving it, so try to build up right angle triangle each time. The highest one, the longest side I could actually have is when P is coming to the y-axis. What is the coordinate of P in the y-axis? That would be 0 and 1. Did you see that? And then when I come to here, that would be, my x coordinate will be negative and my y coordinate is still positive. But what I'm trying to say is that the longest distance P could have with with the x-axis would be 1. So we know that sine theta is definitely below or equal to 1 because it cannot be larger than 1. Okay, and how about if I rotate clockwise and rotate to here and here? If you think about it, I'm on a unit circle. Okay, I'm on a unit circle, and my y coordinate could be minimum -1. So sine theta has to be above equal to -1. And same with the cos theta. If you think about it, it represents the x coordinate. So the largest number it could be is +1. Do you see that? That's when P is here. Has 1, 0. There's no sine theta here. Okay, no sine theta here. So cos theta is also has to be below +1. But when cos theta coming to here, and that's gonna be the -1. Okay, so if you get a result of sine theta equals to, say for example, if you get a result of sine theta equals to 2, then that's absolutely wrong because it's impossible, because sine theta has to be above -1 and below +1. Okay,